This is 2021, and this is question 6. Okay. Now, to deal with arithmetic sequences is right, and this has nothing to do with the question. All right. So imagine I set up 4 terms of a sequence. Okay, and here's what it is. I just, for argument's sake, say 2, 5, 8, and 11. So the common difference is 3 every time. Okay. Now, what I can set up here is an equation where T3 minus T2, the difference between 8 and 5 is 3, and that has to equal the difference between T2 and T1, because T2 minus T1 is also 3. And the gap for any arithmetic sequence means that T3 minus T2 will always equal T2 minus T1, provided the sequence is arithmetic. So using this common knowledge from these type of sequences, what we're going to do next is we're going to do basically, this is your T1, that's your T2, and that's your T3. And we can set up this formula here. 1 take away T2 is the same as T2 take away T1. Now T1's minus 5, so it's going to be minus 5, which is plus 5. Okay, so just get rid of that minus there. That's going to be k plus 5. Bring k to the right, and we're going to get 2k, because it's going to turn into a plus k. Bring the 5 to the left, it's going to turn into a minus 5. But there we're going to turn out that minus 4 equals 2k. So 2k equals minus 4, and therefore k must equal minus 2. Now all of a sudden, it can be quite obvious what the common difference is. We can see that it's going up 3 every time, plus 3 every time. If you want, you can do common difference equals T2 minus T1, and that will be, minus 2 minus minus 5, and that will get you your plus 3. So your value is 3. Now, find T10, the 10th term in the sequence. And so what I use, this formula is in your tables, only for arithmetic sequences. Okay. Now, the A value is your starting value, or your A value is your T1. And we look up here and we go T1 is minus 5. The D value is your common difference, which is 3. We can multiply that in here, and we can get 3n minus 3. And then at the end of the day, we're going to get 3n minus 8. Now, the great thing about this equation is it kicks back any term you want. If you put in T1 and replace n with 1, you get 3 minus 8, and the answer is minus 5. And you knew that that answer was going to be minus 5. Okay? And it'll kick back any term you want. If you were to do T3 as an example, it would kick back the answer of 1. So if I did T3, it'll end up being 3 times 3, take away 8, 9 take away 8 is 1. So that's how this works. You replace the n value with what term you're looking for. So in this case, I'm looking for the 10th term. So because I'm looking for the 10th term, I'm going to replace the n value with 10. So it's going to be 3 times 10, take away 8, and it's going to be 30 take away 8, and the answer is going to be 22. Now the next question on is ask me, find which term in the sequence has a value of 247. Which term? So are we being asked for T247, or are we being asked for Tn equals 247? T247 would be what value is the 247th term. Okay? While Tn equals 247 is which term, which n value causes an answer of 247. So we get our Tn formula, which is the 3n minus 8, and we go 3n minus 8 equals 247. Bring over the 8 and we add it on. So I'll be adding on that, and that'll get me 255. And then 255 divided by 3 is 85. So n equals 85. Alrighty then. Now, the next question is, the first three terms of a different arithmetic sequence are 4, 9, and 14. Find S50. Oof, this is a tough question, right? So with this new term, we're talking about A equals 4, your D value is 5. Okay? Now, there's a formula for Sn, and it's in your log tables. It's n over 2, 2a plus n minus 1 times d. Okay? But the n value is 50. So we just have to fill in all these numbers to make this work. Okay, so the numbers we got to fill in are your n, your a, your n, and your d value. And then we can just use the calculator outright to get the answer. It's going to be 50 divided by 2, 2 times 4, n minus 1, that's 50 times 1, which is quite simply 49. And then multiplied by the d value is 5. And I'm pretty sure I could enter all this into the calculator, and it should be no big deal. 50 over 2, 2 times 4, plus 49 times 5. And we get 6,325. Okay, and that's my answer for S50. The first 50 terms, all added together, will be 6,325. Yeah, that makes sense. All right. So this question here, which is question A, what happens is if you want to make a box like this, you start off with a sheet of paper, okay? And what you do is whatever height you're looking for. So imagine you were looking for a height of 3 as an example. If you're looking for a height of 3, what you got to do is you got to cut off 3 of both sides. So now it's actually 10 take away, like, sorry, 1, 2, 3. 3 is actually probably just that little bit too tall. We'll go for 1.5, okay? So you take away 10, you take away a 1.5 here and a 1.5 here. So that means it's going to be 10, take away 1.5, take away another 1.5. That means that this distance here will only be 7. Okay? So imagine your length would be 7 if the height was 1.5. And likewise here, this length from here to here would be 1.5. This length from here to here would be 1.5. And once again, that leaves this length here as 7. Okay? And that would be what would happen if you're using a height of 1.5. We're not using a height of 1.5, we're actually using a height of x. So here's what has to happen instead. So this is x here and this is x here. So what we're going to do is it's 10 take away x and take away x again. And that will actually be 10 minus 2x. And it's exactly the same thing for the other side as well. So this side here and this side here, the two of them will be x's. And then you're going to get your distance of 10, which is from here all the way down to the bottom. The full length is 10, but then you got to take away the two x's to find out what the yellow length is. Which is this length here. And once again, it will quite simply be 10 minus 2x. And this is for a height of x. All right. So 10 minus 2x, 10 minus 2x, and the height is quite simply x. Okay, show that the volume can be written like this. Now, the volume is length multiplied by your width multiplied by your height. So, in effect, you got to multiply all of these by each other. Okay, when you're doing multiplication, quite simply, take 2 at a time. So here's what we're going to do. So if you're multiplying 2 by 3 by 4, you always take 2 at a time. 2 times 3, 6. Then you take 2 at a time again. 6 times 4, 24. We're going to do the same thing here. We're going to do 10 times 10 to get 100. 10 times minus 2x to get minus 20x. Minus 2x times 10 to get minus 20x. Minus 2x multiplied by 2x is 4x squared. We're going to add the two 20x's together in the middle to get minus 40x plus 4x squared. And then you're going to multiply that by the x here. Multiply it in. 100 times x is 100x. Minus 40 times x is minus 40x squared. And then finally 4x times x is 4x cubed. And what you see is that this answer here is exactly the same as the answer up here. Never mind this phi x business here. You see the 4x cubed? The 4x cubed is here, that's there. The 40x squared, they're both there as well. And the 100x is here and here. So I have definitely got the same answer in this case. Okay, so just going to remember that 4x cubed minus 40x squared plus 100x. So 4x. Now, next question. Why can you not have a height of 6 units? Why can you not have an x value of 6? Well, here's the deal. Remember the length was 10 minus 2x. If you sub in 6 into this, your length will be 10 minus 2 times 6. And then your length will be equal to minus 2. So basically, the reason being is your length can't be negative. Length cannot have a negative value. At x equals 6, the length will have a value of minus 2. Okay, happy days. Let's move on to question D. Now, it gives us this function here, and it wants to know the volume for different x values. So, different heights. So, if we sort of go back to where we were at the beginning, if I change the heights, I change the other values. So, as an example, if I say a height of 1, that will result in a breadth of 8 and a length of 8. Right, and that'll be one value for volume. It'll be 8. It'll be 8 multiplied by 8 multiplied by 1, which will be a volume of 64. If I do a height of 2, it's going to be 2, but this time this is going to have to be a 6 because it all adds up to 10. So it's going to be 2 times 6 times 6. And what's happening here is it's 2 times 6 times 6, which is 72. All right, so every different value of x gives a different volume. Okay, so that's what this equation does here. It tells us all the different values for the volume. So what we can do is we can go to our table function in our calculator. We go mode setup, and we do 4 x cubed minus 40x squared plus 100x. Okay, now notice the 0.5. See the way it goes 2 to 2.5 to 3? So what we're going to do here is we're going to start at I suppose 0, and we're going to go up to 5 with a we're going to go up to 5 with a step of 0.5. All right, so we got 0, we got 64, we got 73.5. We got 72. We got 2.5, which is 62.5. We got 3, which is 48. We got 3.5, which is 31.5. We got 4, which is 16. Now they're quite nice in this exam because they tell us what 4.5 is, but that 4.5 is 4.5 means we're definitely correct here, and that's a 0. Now I'm going to have to draw these out, unfortunately for me. So 0, 0, located here. 0.5 is 40 and a tiny bit, 40.5. 1 and 64. So this is 1 and 64, so it's below 65. We're going to go 1.5 and 73.5, 73.5 around here. We're going to go for 2 and 72. So 2 and 72, that means it's actually lower. So 2 and 72, 72 is about there. We're going to go for 2.5 and 62.5. So 62.5 around here. Has to be below 64. Then we're going to go for 3 and 48. 48 just below 50. And then we're going to go for 3.5 and 31.5 out here. And then we're going to go for 4 and 16 out here. And finally 5 and 0. Oh, sorry, 5 and 0. And what did we say? 4.5 and 4.5 out here. Right? This graph looks something like this. The graph has a maximum around here. Okay. Now, I'm using my drawing pad, which sometimes isn't the best for this type of thing. So I did my best there, okay? Now I'm interested to see the gap halfway between 1.5 and 2. So what I can do here is I can go back and do a step 0.25. So I'm interested in 1.75 if I'm being honest. Yeah, 1.75 is higher than 1.5. So it goes up a little bit and then comes back down again, right? So something like that, just to be aware of it. It isn't the maximum. The maximum's somewhere else. Okay. Now, use your graph to estimate. Now it's an estimate, but I sort of have it here. It's about 74. At 1.75, it's very close to 74. So that's what I'll probably go for. 1.75 is probably what I'll aim at. I'll probably go like straight up, like so. And I'll just claim that that there is 74. Okay, and my calculator more or less told me it is 74. Now what's the unit? Centimeters, is it? Go back to the start. Units, just units. It didn't tell me where centimeters or meters. So units squared. Find the value of x, which will create a box which has a volume of 30. So let's go to 30, which is this part here. Draw a line going straight across. And there's 30 right there. Now, just an estimate, I say about 0.3, 0.4 maybe, and about 3.7. Maybe 3.6, 3.5, 3.6, 3.7, about 3.6 and 0.4. There's a margin of error there. It says values, which is two values, so 0.4 and 3.6. Find the volume of the box when x is 2.8 units. So where's 2.8 on our graph here? 2.8, once again, this is a rough estimate. 2.75 will be roughly halfway, 2.8 just above the halfway, and I'd go for around 52 units. And once again, I can sort of cheat with this. See the way I have this set up? So 2.75 is actually just around the 56 mark, because 2.75 is around 55, so 2.8 would be pretty close. So I'll probably just say that that's sort of a mistake on my graph. My graph got a bit wobbly at that stage. It should have been a bit higher. So it should have been just that little bit higher. But once again, I know how to correct these things. For me, it's about 55, but realistically, it's telling me it should be close to 56. But you do your best with the estimates. 55 units. Oh, sorry, volume. Oof, almost made a mistake there. Volume is units cubed, not units squared. Okay, so units cubed, meters cubed, centimeters cubed. It's always cubed. Now, so that is question 8 and 6, 8 and 9 on the 2021 paper, we're hoping. Okay, so let's keep going. So what's happening is the dots are handy because it's 1 dots, 2 dots, 3 dots. So the next one has to be 4 dots. Okay. Now, T1 has two rows, so to speak. T2 has 1, 2, 3 rows. T3 has 1, 2, 3, 4 rows. So T4 should have 5 rows. and I reckon it'll be something like this. That's 2 rows in total. It's 3 rows in total. That's 4 rows in total, and that there is 5 rows in total. Okay, so happy days. There is my one. Now we're going to find a formula for the number of dots in the pattern. Well, the dots in the pattern are quite easy. It's 1 dot for the first pattern, 2 dots for the second pattern, 3 dots for the third pattern, and 4 dots for the fourth pattern. So that'll be T1, T2, T3, T4. Now we'll go through the usual process. Okay, it's an arithmetic sequence with a D value of 1 and an A value of 1 because the starting term is 1. So we're going to use Tn equals A plus N minus 1 times D. And what we're going to get is Tn equals A, which is 1. D value is 1. And we just get N minus 1. 1 take away 1 is nothing. So Tn equals N. That is an arithmetic sequence, and that there is your formula. Find the total number of dots in the first 20 patterns. Now, please remember, if T1 is 1, T2 is 2, T3 is 3. What they're asking for is the total number of dots. They're asking for an S formula. So, for example, is S3 would be T1 plus T2 plus T3, which would be 1 plus 2 plus 3, which would give me 6. Now, there's a formula that does this for us. You could add all the way down to 20. You'd be well in your right to go all the way down to 20. As in, do it like this. Like, you could literally do it on the calculator. You could just go 1 plus 2 plus 3 plus 4 plus 5 plus 6. And you can literally go all the way down to 20, and that will work. But there is a formula that's meant to make life a bit easier. This formula is available on your tables. It's Sn equals n over 2, 2a plus n minus 1 times d. Okay, and what we know from our formulas is that a is the T1 value, a is 1, d is the common difference, which is also 1, and your n value is 20. And what we can do here is we're just looking to sub in the parts that we listed above, and what we're going to get is 20 divided by 2, which we all know is 10. 2 times a, which is 2 times 1, which is quite simply 2. N, which is 20. 20 take away 1 is 19. 19 times 1 is just plus 19. Okay, and 20 divided by 2 is 10. 10 times 21 equals 210. Adds up to 210. Okay, the table shows the number of crosses for the first 4 patterns. Complete the table. So the first one is x's. So we're talking about the x's. It's 1, 4, 9, 16. Okay, so it's 1, 4, 9, 16. Now these are square numbers. Okay, so these ones are square numbers. What I mean by square numbers is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Next one's going to be 5 squared to be 25, and then 6 squared is going to be 36. So that's what that is. And then it's whatever number you're looking for, you're just going to square it. So if that's n, it'll be n squared, because 6 was actually 6 squared. 5 was actually 5 squared. So if it's n, it's going to be n squared. Okay. Now, find the number of crosses in pattern 12. No bother. So for this sequence, it's Tn equals n squared. Replace n with 12 to get T12. And you're just going to get yourself 144. Okay. Find the number of shapes, dots and crosses in pattern 10. So we're going to do T10 for both sequences. So there's two formulas. So your dots is Tn equals n. Your crosses is Tn equals n squared. So you can do them separately. You can do T10 for both of them. T10 for both of them would be 10 dots and then 10 squared, which is 100 crosses. And then combined, we're just going to get 110. Okay. Now, the first two patterns in a sequence of patterns of crosses are shown below. The number of crosses in pattern n is Tn. In general, Tn can be described by writing the following formula. This is a quadratic sequence, not a linear sequence, just because we can see the n squared. Use substitution. That usually means replacing the n value with a certain number, and it actually tells us we should use T1 and T2. Let's do exactly what the question tells us to do. T1, replace all n values with 1, b times 1 plus c, and we know that T1 equals 1 because it's one of them, and we know that T2 equals 3 because there's 3 of them. So we know that this answer has to actually equal 1. So T1 is going to be a half when you put that into the calculator, plus b plus c equals 1. We're going to bring this half over to the other side, and we're going to get b plus c equals 1, take away a half, which is a half. Okay, now it does actually want us to show what T1 is and what T2 is. So T1 is 1 and T2 is 3. And yeah, so I filled in what T1 is there. Now I'm going to have this formula here. It looks like a simultaneous equation. Now I'm going to fill out what T2 is. T2 means replace all n values with 2. So we have 2 squared over 2 plus b times 2 plus c equals 1. I'm going to have 4 divided by 2 is 2. I'm going to have 2b plus c equals 1. I'm going to bring over that 2, so I'm going to have 2b plus c equals 1 take away 2. 1 take away 2 is minus 1. And here lies my two equations, my two simultaneous equations. Now, sorry guys, I just have to realize I sort of jumped the gun here a little bit. I'm actually sort of doing part 2 already, when I should be actually just doing part 1. So I'm just going to take it back a step. Just have to reread in that question. It wants me to write T1 and T2 in terms of B and C and a number. So what I really should have done, I just got ahead of myself there. Just trying to do it all in one go. Leave the 1 alone, and it's basically a half plus B plus C. And this one here is essentially just 2 plus 2B plus C. So the actual answers for this one are this one here, this one here. Okay, so just sorry, I got ahead of myself. Okay, so hence or otherwise find the value of B and C. So we know that T1 is 1. So we know that a half plus B plus C equals 1. Bring the half over the other side like we did earlier. And we get B plus C equals 1. Take away a half, which is a half. And then we know that T2 equals 3. That means that 2 plus 2B plus C equals 3. Bring the 2 to the other side, and we get 2B plus C equals 3. Take away 2, which is 1. Now, all of a sudden, we have a simultaneous equation. I'm going to elect to get rid of the C values. So what I'm going to do is I'm going to see this C value here. I'm going to multiply that by minus 1. I'm going to get minus B minus C equals minus a half. Then we're going to add downwards. And we're going to get is B. 2B take away B is B. And then we're just going to get 1 take away a half is a half. So B is also equal to a half. Okay. Now, if B equals a half, we already know that B plus C equals a half. So if B equals a half plus C is a half. That means the C does nothing. So this means C has to equal 0. So I've found the value of B and the value of C right here. Okay. And that is the end of 2021 questions 9, 8, and 6. 6, 8, 9, 2021.